Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video I will do a demonstration on how to configure IPv4 static and default routes. This is packet tracer 6.2.2.4 of semester 2. Okay, so if I just open my packet tracer files, and control, and the packet tracer files are here. So I need 6224, which is this one here. Okay, now the packet tracer has loaded. I'm just going to cancel this user profile. This is our network, so I'm just going to put this to the side of it. And then this is our activity, so I'll just bring this activity on the left here. Objectives for this activity is part 1, examine the network and evaluate the need for static routing. And part 2, objective is configuring static and a default routes. Then the objective is part 3, is verify connectivity. A small background. In this activity, we will configure static and default routes. A static route is a route that is entered manually by the network administrator to create reliable and safe routes. There are 4 different static routes and are used in this activity. Recursive static route, a directly attached static route, a fully specified static route, and default route. So static routes are very useful in small networks, and when the routes don't change that often, and you can manage it very easy. Now for internet, for example, you can't configure static routes because things change every second, and you as an administrator, you have to go there and manually update everything. So it's not scalable at all. But static route is very secure, which means that's why it says here reliable and a safe route, which means that static routes, they don't share the information, they keep it to themselves. Plus, if there's not enough resources on the router, static route is the best route. There's times when you really have to configure static routes and times where it's not possible, like the internet. Okay, so this is our network. We have 3 routers. Each router has got his own local area network. So part 1 of this activity is to examine the network and evaluate the need of the static routing. Looking at the topology diagram here, how many networks are there in total? So if you look at it here, we see router 1 has got a local area network, has got another network connected to router 2, so that's 2 networks. Router 2 has got a local area network, so that's 3 networks in total. Router 2 is connected directly to router 3, so that's 4 networks in total. And router 3 has got his own local area network. So in total, we have 5 networks here. How many networks are directly connected to each router? 1, router 2, and router 3. Router 1 has got directly connected local area network and directly connected between router 1 and router 2, the network here, wide area network. So router 1 has got 2 networks, 2 directly connected networks. Router 2 has got the wide area network with router 1 and one wide area network with router 3, which is 2 networks, and it's got its own local area network. So router 2 is got 3 directly connected networks. Router 3 on the other hand has got a local area network and 1 network connecting with router 2. So in total, router 3 has got 2 directly connected networks. How many static routes are required by each router to reach network that are not directly connected networks? Okay, so router 1, you don't need a static route for this, for S1, where it's connected here, because it's directly connected, or a static route for here. So directly connected networks don't need any routings, don't need any static route or dynamic route. Router 1 needs to know how to get to LAN of router 2 and LAN of router 3, plus this wide area network between router 2 and router 3. So router 1 needs 1 static route, 2 static routes, and 3 in total static routes. Router 2 has got 3 directly connected networks, but it needs a static route to connect to the router 1 local area network and router 3 local area network. So router 2 needs 2 static routes. And router 3 is similar as router 1. It's got 2 directly connected networks, but it needs 3 static routes. 1 to connect to router 1 local area network, 1 to connect to router 2 local area network, and 1 the wide area network between router 1 and 2. Okay, so here. We were here. Test connectivity to the router 2 and router 3 local area network by pinging PC2 and PC3 from PC1. Why were you unsuccessful? Okay, let's have a look there. So we go and open PC1, go to desktop, command prompt, and we need to ping PC2 and PC3. So if I move this side and just go above to see the IP address. So PC2 IP address is this 172.31.0.254. So I'm going to ping that address. So ping 172.31.0.254. And it says destination host unreachable, which means didn't work. And I'm getting reply, but the reply is coming from my default gateway. Okay, I'm assuming that's a default gateway. But to see that, we can do ipconfig, and yep, that's the IP address of my default gateway. So I cannot ping router 2, PC2 from PC1. Well, the router says hasn't got any route, destination host unreachable. Okay, let's see if we can ping PC3. So ping 172.31.1.190. Same thing. The router or default gateway is telling me that that's it, destination host unreachable. So if I go to router 1, right, CLI, let's move this to the side, and here we're gonna see what does router 1 know, what route does it know. So enable show IP route. It's like asking where do you know where to go. Router 1 says, okay, well, I know only where I'm directly connected. Only those places I can get you. I can get you to network 172.31.1.0 because I'm directly connected, and I can get you to network 172.31.1.192 because I'm directly connected. Okay, these are the local interface IP addresses. So that's the reason why you can't get PC1 cannot ping PC2 or PC3, because router 1 doesn't know how to get there. So we need to create some static routes. So part 2, just go with up there. Okay, why were you not successful? Because there's no routes on router 1. Configure static and a default routes. Configure a recursive static route. So what is recursive static route? Recursive static route means that when you place a route in a routing table, you don't tell the exit interface, you tell the IP address of a neighbor. So for router to find out how to get to that destination, it needs to do another lookup and find out how to get to that IP address as well. Okay, so let's do one static route. So we're going to configure terminal. I'm going to configure a static route towards local area network of router 2. So if you look, that's the router 2 and that's the local area network. So we're going to configure a static route towards there. If I can highlight it, very good. That's it. So IP route to get to that network 172.31.0.1, .0 in the end, that's a network address. 255.255.255.0. What do you want to do? So I'm saying, okay, well, I'm going to send it to my neighbor. So the neighbor's IP address is this 172.31.1.193. So 172.31.1.193. Excellent. So now the router 1 knows when he gets a packet to get to the destination 172.31.0.0, this network is going to forward it to this IP address. But it needs to find out, okay, well, great, I need to forward to that IP address, but I need to do another lookup to find out what interface I need to exit to get to that IP address. So if I do show IP route, now you see that I have one static route here. The network 172.31.0.0/24 via this IP address 172.31.1.193. Great. It's done the lookup. It found out, okay, well, I need to get to this to send it to this IP address. Now I need to do another lookup to find out how to get to that IP address. So to get to that IP address, we're gonna use this directly connected network, 172.31.1.192/30, and it says through serial 000. Excellent. Now it knows what interface it needs to exit to get to that IP address for the destination 172.31.0.0. Okay, that's one static route already configured. So now we need to do another static route towards router 3 local area network here, towards this network. Okay, so config T IP route 172.31.1.128. That's a network address. You can put the IP address, it's just gonna fix it for you. But you really need to put the network address. So 255, the subnet 255.255.255.192. And what to do? To get to this network, we need to send it to the neighbor's IP address. So 172.31.1.193. Okay, now we have two configured static routes. Show IP route. We can see that we have one we configured early, and another one we just configured just now. So this is called a recursive static route because we are already given an IP address. We are not given exit interface, right? So directly attached static route is, for example, if you give exit interface, instead of the way we are given here, neighbor's IP address, we can't put our IP address. It has to be the neighbor's IP address or our exit interface. If we do a exit interface, then it's directly attached static route. But we can do both. We can do exit interface and a neighbor's IP address, and that is called fully specified static route. We need to do another static route for router 1, config T, and IP route, and this static route is for the network. If I remove this network here. The first static route we did was for this network. The second static route was for this network, and third static route is going to be for this network here, 172.31.1.196. Okay, so if I go there, router 1, IP route 172.31. What was the IP address? .31.1.196. And then the subnet mask. Subnet mask is /30. /30 is 255.255.255.252. And then for router 1, we're going to do everything is going to be the neighbor's IP address, which is 172.31.1.193. End. Okay, so show IP route. So now router 1 has got 3 static routes. Without seeing these directly connected or local routes, we're just gonna say show IP route static. So we can see that we have 3 static routes. Administrative distance of 1. Okay, now if PC1, we go back to PC1 and try and ping. Say we're gonna ping, let's ping PC2. So 0.254. That's PC2. We can not still ping it. What do you think is the reason? Well, think about the reason. Static route means, well, to get to the destination, maybe you can get there, but you know how to come back. So routing is two-way. Is you can get there, but you need to come back as well. The router 2 needs to know how to come back towards router 1. So if we go to the simulation here, for example, let's choose simulation. Let's expand this. And yeah, ICMP is fine. When we ping from this PC to this PC, we see where the packet, what's happening to the packets. So capture forward. It's going to router 1. Router 1 is sending it to router 2. Okay, so it's going to the destination. Right? So it's reached PC2. It's going to reach PC2. Great. And then PC2 is going to reply. Say okay. And you can see router 2 doesn't know how to get to the destination. So it will fail there. So it's failing there. Okay. So go back to the real time. Okay. So here, what does a recursive static require? Two recursive lookups. Yep. Configure recursive static route to every network not directly connected to router 1, including wide area network name between router 2 and router 3, which we did. Test connectivity to the R2 LAN and ping the IP address from of PC2 and PC3. We did ping PC2. There's no reply. We're gonna ping PC3 now. Same. Not gonna be a reply. So go to PC. And the IP address of PC3 was 172.31.1.190. No reply. But now it says request timeout instead of saying, before it was saying reachable, which was our gateway telling us. This one is going all the way to the destination and it's getting lost somewhere. Okay, great. Now in step 2, why are you unsuccessful? Configure directly attached static routes on R2. That's the reason, because R2 doesn't know how to get to the destination. How does a directly attached static route differ from recursive static routes? Configure a directly attached static route from R2 to every network and directly connected. Now think about it. Early we did a recursive static route, which means that we did put an IP address of the neighbor as a destination, right? The next hop. So for example, the configuration was here. So that's our, to get to this destination, so IP route, to get to this destination, 172.31.1.196, with this subnet mask, we put as the neighbor's IP address. Now that's a recursive lookup because the router is going to look up, do the first lookup, find out, okay, I don't need to get to this destination. Now to get to this destination, I need to send it to this IP address. But now I need to do another lookup. How do I get to that IP address? What exit interface I use? Now, a directly connected static route, we're going to configure on router 2. So open router 2, CLI. Now router 2 has got 2 networks that it needs to get to. So if I just maximize a little bit here, I can shrink this a little bit. So if you look, router 2 has got directly connected one, hit this side, wide area network, directly connected the other wide area network, directly connected LAN. So it doesn't need about this route. It needs a static route to this network, right? So, okay. So let me just try and, okay. So enable, configure, terminal, then IP route to get to this network, from router 2 to this network, 172.31.1.0, 255.255.255.128, since it's /25. Now we need to go out of this interface. Exit interface is going to be this one. So serial 000. That's directly attached static route. So S000. So we're saying to get to this network, go out of this interface. That's a directly attached network. And we need to, it says we default route without gateway if not a point-to-point interface might impact in performance. That's why it's a point-to-point. It's better if you put the exit interface. Well, fully specified static route will be the best. Now, from router 2 to get to this network, right? So IP route 172.31.1.128, 255.255.255.192, because that's the subnet mask. We're going to go out of this interface, which is S0001. So if I just click on it, or hover around it, don't only click, S001. So S001. And show IP route. Now let me maximize this so we can see it. Okay, show IP route, again, static. So you can see I have 2 static routes, but both are static routes now, and they're not giving me exit interface. No, sorry, they are giving me the exit interface. They are not giving me the neighbor's IP address. Right. So now router 1 knows how to get to this LAN. Router 2 knows how to get to this LAN. So the communication should be successful. If I ping from PC1 and I ping PC2, which this is the address. So if you look again, find out the address of PC2. 172.31.0.254, which is true. This should be successful, and it is. Router 1 knows how to get to LAN of router 2. Router 2 knows how to get back to LAN of router 1. So it's successful. But PC1 will not be able to ping PC3. So will not be able. The ping will go that way, then there, then they will go to that destination, then to the destination of PC3. Then when they come back, they will get stuck here. So you need to create a static route on router 3. Okay, now let's see a little bit here what they're asking us to do. So when viewing the entire routing table, how can you distinguish between a directly attached static route and directly connected networks? Okay. Which command, let's go back. Which command only displays directly connected network? So what commands we need to type? So if I go to router 2, show IP route is showing us everything. Directly connected and static routes. Now what commands we're gonna see only directly connected? Show IP route connected. This will show you only directly connected routes. So as we can see, we have 3. Router 2 has 3 directly connected networks. Then the question is, which command only displays the static routes listed in the routed table? Okay, so show IP route, we did this earlier. Show IP route, static. Okay, we can see the two. Now, when viewing the entire routing table, how can you distinguish between a directly attached static route and directly connected networks? Right? Directly attached static route and directly connected networks. Well, when we do a show IP route, for example, we can see the directly connected networks have the C, the code, and static route has S, the code. Configure default route, that's step 3. How does the default route differ from a regular static route? Configure default route on R3 so that every network not directly connected is reachable. Okay, so if I go to R3 now, directly connected route. So for every network, right? So it doesn't matter what networks. Okay, so enable config T. So IP route, all zeros, any network with any mask. What we're gonna do? Where are we gonna send it? We can send it out of the serial interface or to the next hop neighbor or next neighbor's IP address. So let's do a serial interface. 0001. How is static route displayed in the routing table? Okay, so and show IP route static. As we can see now, okay, just say show IP route without static. Now this static route is a bit different, yeah? It has an S and a star. This star says it's candidate to be the default route. Default route meaning gateway of last resort. So if you don't know, if you can't find any better destination, now this is gonna be the last resort. We use exit out of the interface S001. Okay, so now if you ping, we go to PC1, we ping PC2, so that was successful, and it still is. And let's ping PC3. This is PC3, 172.31.1.190. Okay, first we lost from one timeout, ARP, and then pinged are successful. So if we do it again, it's gonna work now 100% all the time. I just went there back to see if I put the IP address correctly. Okay, now document the commands for fully specified route. Packet Tracer does not currently support configuring fully specified static route. Therefore, in this step, document the configuration for fully specified route. Explain a fully specified route, which command provides a fully specified static route from R3 to the R2 LAN. So if we go to R3, for example, fully specified route, you say config t IP route, and then IP say default route, yeah, default route, and then we say the exit interface, so 1, and then we put the IP address of the neighbor. So 172, for example. What was the neighbor's IP address? 172. I don't know. The neighbor's IP address 172.31.1.197. Okay, that will be the default, fully specified static route. You are telling the exit interface and the neighbor's IP address. Thank you for watching my video. On this demonstration, I showed you how to configure an IPv4 static and default routes. Bye bye, see you in the future videos.